Writing in vertex form. In this video, you'll learn to identify the vertex of a graph of a quadratic function when the expression that defines it is written in vertex form. You'll also learn that when given a quadratic expression in standard form, how to rewrite it in vertex form. We've learned a few different ways that we can write a quadratic equation. We have standard form, which is y equals ax squared plus bx plus c, and we learned vertex form, which is y is equal to a times x minus h squared plus k. And we also have factored form, which is y equals x plus m times x plus n. The standard form is good when we want to find the y-intercept, and the vertex form is good when we want to find the vertex. And factored form is used when we want to find the x-intercepts. Let's look at how to convert standard form to vertex form. If we have the equation y equals x squared plus 10x plus 26, which is in standard form, we're going to start by grouping the x terms. So we'll just put parentheses around those x terms. Now we're going to find the number that completes the square. So we're going to take our formula of b divided by 2 squared and replace b with 10. 10 divided by 2 gives us 5, and 5 squared gives us 25. Now we're going to add this value and its opposite. We do this because if we add like positive 25 and negative 25, it's the same as just adding 0, so it doesn't change the value. So we're going to add 25 to the parentheses and then subtract 25 from the constant. This gives us y is equal to x squared plus 10x plus 25 plus 1. Now we're going to rewrite the parentheses as a perfect square. So we can simplify this to x plus 5 squared plus 1. Now we can see that it's in vertex form. In this example, we're going to rewrite the quadratic in vertex form, and then we'll give the coordinates of the vertex. We'll start by grouping our x terms and putting parentheses around them. Now we're going to find the value that completes the square. So we'll take half of b and then we'll square it. b is negative 20, and when we divide that by 2, we get negative 10. Negative 10 squared gives us 100. So we're going to add 100 to the parentheses and subtract it from the constant. Since if we add a positive and negative to the same side of the equation, it's the same as just adding 0. This gives us y is equal to x squared minus 20x plus 100 minus 81. We can simplify this to factored form, x minus 10 squared, and now we can see that it's in vertex form. We can see in vertex form that 10 is h and negative 81 is k. So our vertex happens at 10, negative 81. In this example, we have 3 quadratic expressions that all define the same function. We're going to use the forms to determine the vertex, the x-intercepts, and the y-intercept of the graph. Let's start with our first equation, which is in factored form. So we can use this to find the x-intercepts by setting each parenthesis equal to 0. We'll solve by subtracting 5 from both sides. So this gives us x is equal to negative 5. Now we'll subtract 3 on the other equation, and this gives us x is equal to negative 3. So our x-intercepts happen at negative 5 and negative 3. Now let's look at our next equation. This one's in standard form, so we can use this to find the y-intercept. The y-intercept is represented by our constant term of 15. So the y-intercept happens at 0 and then 15. Our last equation is in vertex form, so we can use this to find our vertex. Vertex form looks like y equals x minus h squared plus k. So we can see that h is negative 4. Since it says plus 4, that means that they must have subtracted a negative. And then k is negative 1. So our vertex happens at negative 4, negative 1. In our last example, we're going to rewrite each quadratic in vertex form. We'll start with y equals x squared plus 12x plus 36. We'll group our x terms, and then we'll find the value that completes the square. b becomes 12, and half of 12 is 6. 6 squared gives us 36. So we'll add 36 to the parentheses and subtract it from our constant. This gives us y is equal to x squared plus 12x plus 36. We can simplify this to x plus 6 squared, and now it's in vertex form. So let's look at the second equation. We'll start by grouping those x terms, and then we'll find the value that we want to use to complete the square. b becomes 10, and half of 10 gives us 5. 5 squared is 25. So we'll add 25 to the parentheses and subtract it from the constant. So we get y is equal to x squared plus 10x plus 25 minus 4. We can simplify the parenthesis to x plus 5 squared, and now we have this in vertex form. Now let's look at our last one. First, we're going to pull out the factor of 2. This just makes it easier for us to put it in vertex form. So we're only going to focus on what's in the parentheses for now, and then when we solve it, we'll put it back into those parentheses. So let's group our x terms, and now we'll find the value that completes the square. So b is negative 10, and half of negative 10 is negative 5. If we square negative 5, we get 25. So we'll add this to our parenthesis and subtract it from our constant. So we get x squared minus 10x plus 25 minus 9. We'll put this in factored form of x minus 5 squared. And now we can put this back up to our original equation. So in vertex form, we have y equals 2 times x minus 5 squared minus 9. Now let's summarize what we've learned. A quadratic function can be defined by equivalent expressions in different forms, which enables us to use different features of its graph. We can convert between the three methods depending on what key feature we're looking for. For example, to convert standard form to vertex form, we can use completing the square to create an equivalent equation.